All right, in this lesson, we'll explore yet another way that we can filter data. It seems like they come up with a different way to do this every single month on the Pandas development team. But I'll begin by re-executing our code. And in this lesson, we'll talk about the query method that we can call directly on a data frame. And there's two caveats here. The first is that when we use the query method, our argument will actually be a string. And the second is that this method only works when our column names in our data frame don't have any spaces. And we do have two columns here that potentially can cause a problem. We have spaces here in box office and also in bond actor salary. So before I begin using the query method, I'm going to just do something to fill in those spaces with underscores. So we know that if we call the columns attribute, we'll get an array of the names of our columns. And what I can do is use Python list comprehension to just iterate over every value in this array and replace the column name spaces with underscores. So if you're unfamiliar with this code, just realize it's pure Python and just follow along. So I'm just going to give myself a little bit of space, and I'm going to do column name, which is going to be my temporary variable that stores every column. I'm going to call the Python replace string method, which we've discussed, or actually that we will discuss, sorry, in the next module. And I'm going to replace each occurrence of space with an underscore, and I'm going to do that for column name in my list of columns. And once I get that, I'm going to get a new list and I can see that the results are exactly as I want it to be with underscores in place of the spaces. I can assign this right back to the attribute, and if I preview my first row with the head method, you can see that now we filled in those spaces. Again, if this is unfamiliar, just pause the video and follow along with my syntax to get your columns in the exact same order. And now that we have no spaces, we're ready to dive into the query method. So let's call the query method directly on our data frame, and all methods take parentheses. And the query method basically accepts the kind of regular comparison that you might expect. It's just in a single string, and it also doesn't require the presence of the data frame name, in this case bond, or rather the variable. So let's say we want to extract the rows where the actor value is equal to Sean Connery. What I can do here is begin my string, and I'm actually going to begin it with single quotes. And I'm going to write actor, which is the name of my column, equals, and then Sean Connery has to be represented as its own kind of mini string or embedded string within here. So I'm going to use double quotes here around Sean Connery. So basically we're writing sort of like a more literal string interpretation of what we want to do here. Notice that we don't have to do bond actor, so we don't have to create a Boolean series. We just write actor as the very first thing in our string. We then use the double equal signs, which is comparison, and then we write the value that we want to compare against. And since we have to isolate it or identify it as its own separate string, we have to use an alternate form of quotes. In this case, we're using double quotes. So now if I query this, you'll see that we're going to get those rows that have Sean Connery. Now the query method, from what I've read in the Pandas documentation, tends to be faster than standard syntax, especially for larger data frames. I personally haven't seen this method used a lot throughout other people's Jupyter notebooks, but I just wanted to introduce it in case you run into it. So let's do a couple more examples. Let's say I want to query the director column for the director Terrence Young. So I'm going to do bond query, and once again open my parentheses. And again, since you have to use an alternating combination of double quotes or single quotes anyway, it doesn't matter which order you use them in as long as you vary them up. So I can actually begin the outer string, the main string, with my double quotes and type in director, and then do an equal to compare, and then write my director name in a single quote in order to indicate that that's its own internal string. And again, it doesn't matter which way you have them as long as you're designating that string inside that you're comparing your column values to with the opposite variety of quotes. So there's all of my Bond films directed by Terrence Young. If I want to negate or check where it's not equal to, I can just use my exclamation equal to comparison. So if I want a list of Bond movies where the actor is not equal to Roger Moore, I can do actor exclamation equals Roger Moore in single quotes, and there I have the result of every Bond movie where the actor is not Roger Moore. And everything else works as you might expect. Let's say I want to pull all of the columns. Let's say I want to pull all of the rows where the box office value is greater than 600. I'm just going to open my main string, box office with the underscore, greater than 600. There I have it. Same operation applies for less than, as well as less than or equal to and greater than or equal to. And finally, if I want to do multiple conditions, the syntax is a little bit different. I'm going to do bond.query again. Let's say I want to pull the films where the actor is equal to Roger Moore and the director is equal to John Glenn. I'm going to begin with my double quotes, actor equals Roger Moore in single quotes. And instead of using our ampersand here, our symbol, I'm just going to use the literal word and. So one of the other advantages of query as a method is that it allows your syntax to be a little bit more human, less computerized, and read more like a sentence. In this case, I say I want to query from the Bond data frame where the actor equals Roger Moore and the director equals John Glenn. So now let's fill in the director, which that column, again, I don't have to write in quotes, and I also don't have to place it after my data frame. All of that is assumed. Equals equals, my string comparison here is John Glenn, so I'm going to write that in single quotes. And there I have the rows where the actor is Roger Moore and the director is equal to John Glenn. If I want to use the or operator instead of and, it's not going to be the vertical pipe, it's going to be the literal word or. So there we have all the films that have either Roger Moore or a director of John Glenn, including both conditions. And finally, we can also use the in and not in keywords. So if I want to do Bond query, and let's say I want to do all Bond actors except for Timothy Dalton and George Lazenby, I can begin my double quotes and write actor in, and within here I can actually pass a Python list. And that list is going to contain my actor names in single quotes, Timothy Dalton and George Lazenby. So this is kind of combining internal Python syntax with kind of a regular string. It's basically just putting that syntax inside the regular string and using Python words like in and not in. And now if we take a look at this, we can see that we're only pulling those movies where the actor is either Timothy Dalton or George Lazenby. And similarly, let's say I want to do another query where the actor is not Sean Connery or Roger Moore. I can do actor not in, which is the same as the Python syntax, and then open a list within my string and write the values that I want to compare against in single quotes, Sean Connery, comma, Roger Moore. I'll end that single quote for Roger Moore, and that's going to give me all of the rows where the actor is not Sean Connery and not Roger Moore. So that's the query method. It takes a little bit of familiarity, it takes a little bit of practice to get used to, but it's just another way that we can query a data frame, extract rows that fit one or more conditions. Again, as a reminder, before you use this method, make sure to check that your column names don't have any spaces. If they do, you'll have to run some kind of operation to replace those spaces with some kind of connecting character. And realize that a lot of Python syntactical things, such as and or instead of the ampersand and the vertical pipe, as well as keywords like in and not in, are all valid here. So there is some additional flexibility to this method. It's just another different way that we can query a subset from our original data frame.